Welcome everyone for today's public forum. So this public forum is titled Climate Change and Power Outage. And the organizer of today's public forum is the University Malaya's Research Cluster's office. So let me introduce myself first. So I'm Go Hongqing, and you can call me always Hongqing when you address me. And I'm currently the chair of Social Advancement and Happiness Research Cluster. Um, so since today's right, the organizer is the University Malaya's Research Office, I would like to give you some brief introduction about the research cluster and how we come to have the public forum today. Can we move to the next slide? Okay. Yeah. So just a glance that University Malaya's Research Cluster Office established right back in 2018, and then currently right have 4 research cluster for the University Malaya. So we have the frontiers of the natural world, health and well-being, innovative industry and sustainability science, as well as social advancement and happiness. That's where that I attach to. So the main role of the research clusters office, that's for include to empower the researchers, to enhance the researchers' attributes, and at the same time to connect the researchers and inculcating interdisciplinary research culture. And this is what I'm going to lead next, to how we have this forum under the project funded under IIRG. Then next is to engage with the stakeholders. So meaning that's we are not only working in silo or working what we call always the general public would say that's we are working in the ivory tower, but we would like and we love to engage with the stakeholders outside academia. And last but not least, also to transform the world and to deliver the research impact beyond academia. I think this is something that University Malaya is striving to do for the next decades or even beyond that. Next. So also a glance into IIRG, as I mentioned just now, how IIRG was started back in 2019, sorry. Basically, is that we would like to emphasize on the impact beyond academia, like mentioned just now, and at the same time, we would like to also enhance the effective engagement with our stakeholders, and we recognize that interactions among the researchers from various disciplines are really important, to address the issues that we are facing, not only at the global level, but at the same time in our societies that we are living in. Next. So there comes the objective of the public forum today, to serve as a platform for the researchers to share the outcome of their interdisciplinary research project, IIRG program that I mentioned earlier, to other institutions, industry, community agencies, any other stakeholders that might be interested. Sometimes we think they are relevant, but maybe they are not interested. So this is something that we would like to link the stakeholders who are relevant at the same time, who are also interested in our research as well. And next is that I would like to already introduce to the panels that we have today. We have 3 panels, as you know, and today is to be frank, is that I'm a social scientist and trained as an urban planner, but I'm going to introduce to you there's 2 engineers plus 1 economics that will be the speakers for today. So first, I would like to introduce Prof. Hazli. Yeah. So Prof. Hazli Mukhlis, yeah, is from the Department of Electrical Engineering. He has experience of more than 20 years in teaching, research and administrative capacity in His expertise is in electrical power system, and he is actively involved in consultancy projects and advisor for specific projects under the government agencies. And these are big agencies, including the Malaysian Industry Government Group for High Technology, as well as Department of Standards of Malaysia. Currently, he's the cluster chair as well, yeah, for innovative industry and sustainability science. So it's a dear colleagues of mine at the same capacity at the moment in the cluster office. Yeah. Next, I would like to introduce Dr. Lau Wee Yep. So Dr. Lau is currently an associate professor at the Faculty of Business and Econs, University of Malaya, and previously served as the Deputy Dean for Postgrads of the Faculty of Econs and Administration and the head of Department of Applied Statistics. He is currently elected member of International Statistical Institute, Associate Research Fellows of Malaysian Institute of Economic Research. He was also a Ministry of Education, Culture and Sport and Science and Technologies scholar in Japan at Osaka University and visiting scholars, yeah, at RMI, National University of Singapore, and beyond academia. Yeah. Dr. Lau was formerly the honorary secretary, yeah, of Malaysia Economic Association. So his contributions have also, right, yeah, not only right in terms of within but also right at the national levels as well in his very specific and specialized field. Last but not least, we have also Associate Professor Dr. Hazli Azil Ilyas, yeah, who received his bachelor degree in electrical engineering from the University of Malaya back in 2006. Yeah, we are talking about 17 years ago, and PhD degree in electrical engineering from the University of Southampton, yeah, UK in 2011. And straight after that, he has been appointed as an academic staff in the Departments of Electrical Engineering, University Malaya. Since joining he has received funding and grants of nearly 3 million, approximately US dollars, 0.7 million, published more than 70 journals paper in ISI index publication, and also more than 70 leverage conference papers. And beyond that, he has successfully supervised the completion at least 15 postgrad students, as well as supervised 27 by thought course then. Yeah. He is currently a senior member of the Institute of Electrical and Electronics Engineer, member of Institute of Engineering and Technology, corporate member of Institutions of Engineers Malaysia, as well as a registered chartered engineer in the UK and professional engineer in Malaysia. His main research interests include modeling and measurements of partial discharge phenomena in solid dielectrical insulation, condition monitoring, insulation system diagnosis, lightning over voltage, transmission line modeling, optimization methods, and the artificial intelligence techniques. Yeah. So very, very impressive academics that we have today with us. Yeah. Today, if you take a look in terms of the title, back again to the title, we are talking about climate change and power outage. And normally, as a social scientist, and also urban planner, I remember that when I always think about climate change, I always relate it to food security, then sea level rise, as well as global warming. And however, if you take a look on the recent focus, in the global scale or even at the national scale, is that right? energy security, especially in the future, has become a much bigger concern. And in fact, it can becomes very critical. And if you take a look, right, in the energy sector itself, right, climate change affects the fuel supply, energy production, as well as the physical and the resilience of the current and future energy infrastructure. So with us today is that, we have the three panels going to focus on power outage. And if you take a look in the US itself, right, between year 2000 and 2021, 83% of the reported major outages in the US were attributed to weather-related events. So if we take a look, then we wonder how that right is relevant. Climate change issue is relevant right in our context in Malaysia. And with that right, I hand over to you then, Prof. Hazli.
Thank you, Dr. Go, for the kind introduction. Can you hear me? Clear, yeah? All right. So let me share my slide. Can you see the slide?
And sorry, Prof. Hazli, please allow me to interrupt short while. I think for housekeeping rules, this is for all our
all right, okay, all right.
Today. Yep. There's two housekeeping reminders that I would like to share. The first is that please register yourself at the links that has been put on the chat box. That is for the purpose of registration as well as feedback. And secondly is about the Q&A session, of which we will do it right after all the panels have shared their views. And you can write down your question in the chat box by it, and also introduce yourself, and you can also indicate the questions who you would like the question to be addressed by. Otherwise we'll ask the panels as well towards the end. Sorry again, over to you again then, Professor.
Okay. All right, thank you, Dr. Go, for the introduction and also housekeeping. Assalamualaikum and very good morning to all the audience. Today I would like to share, for start, I would like to give some brief introduction about electrical power system, because I believe that some of the audience the background is not from electrical industry, so that it will be benefited if I can share a little bit about overall overview of electrical supply system to start off. All right, so basically electricity is generated from a generation station before it is distributed to the customer. So this generation system can be a hydro or a big power plant based on the coal or based on the gas. And then from this generation station, the power will be transmitted through a transmission system. And this transmission system is long. It can be 100 kilometer to 500 kilometer in Malaysia. And then from this transmission system, the power will be distributed to the customer according to their voltage level, because at the customer side, there are domestic, there are also industrial, so they have different voltage level. So overall, this is a power system, or we can say the electrical supply system before it reach to the customer, starting from the generation. However, nowadays, beside the central generation system based on hydro or based on power plant, nowadays we have a lot of renewable energies. For example, we have solar, we have wind, we have biomass, we have a mini hydro. So all of this renewable energy, it also can be used to generate electricity, and the power flow now is not from the generation station alone, but it also comes from the renewable energy at the customer side. So if you can see this, the overall system, the system is exposed to the environment. For example, the transmission system, it is exposed to the environment because when there is a lightning, for example, the lightning can strike the transmission tower or the transmission line. Whereas at the customer side, at the distribution side, in Malaysia mainly it is caused by the flood, caused by the flood. So all of this actually will impact the performance of the electricity supply system overall. And if you look at the title, climate change and power outages, actually it is related because whenever there are changes in terms of the climate, the pattern of the lightning, the pattern of flood, it will be intensified and it will cause more harmful to the overall system, and it can disturb the performance of the system. And all of this, we call it low probability and high impact, meaning the probability to happen, it is low. But when it happened, as Dr. Goh said, the losses is very huge in terms of monetary. So this one, maybe Dr. Lau later will describe more about in terms of the monetary, the impact in terms of the power outage to the monetary. And therefore, we need to have a resilient system. When we say resilience, meaning here we want the system, the overall system, has the ability to limit the extent, severity, and duration of system degradation after extreme events, for example, flood or lightning strike. Yeah? So this is where the term resilience power system come from. And if you look at the overall perspective in the world, we can see that the major catastrophic events around the world is very huge. This data taken for 2019, and we can see that overall in the world, there are a lot of catastrophic events due to the climate change. And if we focus in Malaysia, for instance, we can see that in Malaysia, there are a lot of, from the figure here, there are a lot of blue bubble, which is representing floods. It is representing the flood, or we say hydrological events, and one of it is flood or mass movement. And there are a lot of bubble there, and the size of the bubble indicate the impact. And we can see, for example, on the right side, the overall losses in terms of US dollar is huge, it's billion, due to the impact of this extreme weather. And if you look at the, from the perspective of electrical supply industry, and this is few examples whereby we can see that the extreme weather will cause a lot of problems. For example, in 2008, in southern China, 14.66 million households were affected because of 129 lines were faulted due to a severe snowstorm. In 2011, in Japan, Fukushima, when 4 reactors destroyed, 4 million households were affected for 7 to 9 days when the earthquake and tsunami hit Japan. And in US, 2012, due to Hurricane Sandy, 8 million people lost electricity. And in China, 2016, 135,000 households lost power due to a thunderstorm hit. And quite recent, in 2021, in February 2021, there was a major blackout in Texas, southern state of US. This is due to a winter storm where 4.3 million affected without electricity for several hours. And it also caused a lot of damage and also caused deaths to some of the people over there. And this is the reason, because of the storm that caused a freezing on their power plant. So we can see that the climate change caused a lot of problem in terms of extreme weather, and extreme weather caused problem to the power supply industry. If we look at the Malaysia perspective, as we know, Malaysia, in terms of problems, earthquake or drought or haze, it is not much. It's very low frequency, I mean it's not much happen. But the main problem in Malaysia, as everybody aware, it is a flood. And if you look at the data of the flood here, based on this data, we can see that every year we have a lot of flood. And I think it's become very frequent lately in terms of floods. And this flood will continue to happen. If you look at this is happened due to the climate change. If you look at the data on the right side in terms of the temperature, there was an increase of temperature 1 degree Celsius in terms of Peninsula Malaysia or Sabah and Sarawak. So this is indicate where climate change and it changed the pattern of the rainfall, and also it will cause a lot of problem in terms of the power supply system. And in 2014, when there was a major flood in history of our Peninsula Malaysia, if you look at the losses by the electrical industry, TMB lost approximately 100 millions. This happened because a lot of the substation is submerged due to the flood. Yeah. And if you look at the example, this is 2021. Okay, 2021. More than 333 power substation is flooded and it need to be switched off. And we can see the data here is very huge. I mean, a lot of homes affected by the cut off of the power electricity. The same goes recently in 2022, in March, whereby TMB need to switch off more around 40 substation. And basically this substation will distribute the power to the customer. And we can see some of the photo there whereby the Puncawang Electric, or we call it a power substation, is submerged due to the flood. And in a worst scenario, the substation can be exploded. That happened in Shah Alam in Glenmarie due to the short circuit of the flood water. And if you look at the previous data, in 2017, 14, we can see the lot of flood that causes the substation to be switched off, and the number of customers affected is shown that is huge, and the megawatt loss also quite high. So this is the problems in Malaysia, whereby due to the climate changes, the flood intensity is increasing quite huge, and therefore a lot of things need to be we need to do to make sure that preparation can be done well, so that whenever this happen, the TMB or industry able to reroute the power supply or dispatch the generation, for example, genset. So this is for start, explaining about the overall perspective of power system, and also how it impacting the electrical industry and how climate change causes more floods in terms of Malaysian perspective. Okay, I think that's all for the first round. Better go over to you. Thank you.
Thank you so much, Prof. Hazli. I would say is that at the same time that it's so introductory, but at the same time that it's so overview about what happened, and especially when we talk about resiliency, I think this is a concept that we always think that how we actually want to address the issue. But more importantly is that how climate change, especially for a tropical country like us, unlike the four seasons countries, despite we don't have the winter, for instance, but we have another sort of issues when we talk about more frequent and intense extreme events here, the weather. So we are relate that to our raining season. It can be even in terms of the magnitude. It can be much more heavy pour, and we are also talking about much longer raining seasons that cause flood. And this we know about how the populations are affected, the social impacts. That's a lot of study has been done. And I was thinking maybe it is also good, to take a look, when we talk about economic impact itself, when it comes to dollars and cents, how much that actually, we have, have been affected when we talk about the dollars and cents, bearing in mind that being a medium income countries, economic growth, is one of our most important focus then. And with that, over to you then, Dr. Lau, from the perspective of economics.
Okay, thank you, Dr. Kaur. Allow me to share my slide. Just a minute. Okay, this is my slide. Just a minute. Okay, I think you can see my slide, correct? Okay. Basically, as we have seen in by these Sustainable Development Goals, this is by the United Nations. So this energy plays an important role in facilitating our nation's economic growth. And of course, this electricity is the backbone of this modern economic development. So a lot of things that today we need electricity to power, right? The machine, the computer, and so forth. Therefore, the disruption in the power supply, they would lead to interruption in the operation and of the economic sector, and that would affect our productivity and also the cost in the various sectors. And as we can explain by Prof. Huxley just now, in fact, there are many causes of this power outages, right? And I think, as you can see from the slide, of course, we have lightning, then we have flood, and all sorts of other reasons. But I think the number one reason for Malaysia is obviously the flood, right? Okay. And of course, if we look back some history, our history in Malaysia, we have quite a number of blackout or power outages, right? And I remember the one in 1996, basically that is a very, what they call it, happened in 1996, I think. So it basically covers a lot of, a few states actually, a few states. And then another one in 2003. And subsequently, we have another one which happened in Northern Peninsula, 2005. Okay. And the most recent, we have 2015. Okay. And that one is in Sarawak, right? Pakun. But however, it also affects in Kuala Lumpur and Selangor. And of course, the last one is 2022, right? Okay. That was Peninsula Malaysia as well. Okay, and basically how we actually measure this so-called the disruption. So there are basically two index, and this is you can obtain from the Energy Commission's website. The first one is we call SID, System Average Interruption Index. This is the average electricity interruption in minutes, okay, explained by experienced by customers in the year. So basically what happened is that sum of all customer interruption duration divided by total number of customers served. So this index basically focuses on duration, how long duration. And the next one we have is called SIFI. Okay, SIFI is System Average Interruption Frequency Index. This one calculates the average frequency of supply interruption per year. So for this particular formula, total number of customer interruptions divided by total number of customers served. So this one is basically measured by how many times the average frequency, like 1 time, 2 times, you know, how many times that the customer will experience this power outage. Okay, let's move on to the next slide. Maybe this is the data, right? This is the data. You can see the monthly data, right? April 21st, 2021, May 21. And until June 2022. This one you can obtain from the Energy Commission of Suruhanjaya Tenaga website. And you can see that, for example, in June 2022, so this is minutes, right? This is a duration. So per customers, okay, on average, the power interruption or the outage is 3 minutes, 3.3 minutes. Okay, so basically this is in our current research that we use the data from Energy Commission, Suruhanjaya Tenaga, the SID number and also the SIFI number to our research. Okay, I think I will stop here for the time being and pass back to Dr. Gore. Yeah, Dr. Gore.
Okay, thank you so much, Dr. Lau. for that very brief, but then right, some things that I really learned today as well that I didn't know about SAIDI, SAIFI, and also SAFI. I think this is something that really important, right, for us to monitor what we are talking about, especially when we talk about any outage or even any loss. That has to come with the evidence, and I think this will be a good indicators to show, right, the next step. I think with that, I would like already, right, to call upon, right, Dr. Hasley. Um, he's not going to talk about how bad the flood would be. He's not going to talk about, right, the economics, right, point of view about the monitoring, yeah, or even the loss, how we do the calculation. But for him to start, right, he will touch a very important aspect, which the slide or the images was already shown, yeah, in Dr. Lau's slide just now about lightning. And this is a very fundamental safety, yeah, factors that, right, we have to take in, yeah, especially we're talking about, right, the day-to-day life, yeah. Okay, and over to you then, Dr. Hasley.
Okay, thank you very much, Associate Professor Dr. Goh Hong Chin. Okay, so first, please allow me to share my screen. Okay, so is my screen visible? Okay, all right. Okay, so I'm going to talk briefly, okay, about lightning safety, okay, and also some phenomena, okay, power outage related to lightning, okay, and also briefly about that's basic about lightning. Okay, so here are some of the images, okay, that we that have been captured, okay, during lightning thunderstorm days. Okay, so actually lightning is a natural electrical discharge, okay, of very short duration, okay, and high voltage between the cloud and ground, okay, or within the cloud itself. Okay, so a sudden discharge, okay, generates a bright flash and also thunder. So thunder is a noise, okay, that we hear, okay, after lightning happens, and lightning, okay, can strike anywhere, okay, open field, okay, tall objects, and also mountains. Okay, so here are some images of lightning near to the transmission line. Okay, so transmission, like what Prof. Azli has mentioned just now. Okay, so transmission line, okay, is part of the power system. Okay, so lightning can also can affect, okay, the power system. Okay, when it strike the transmission line. Okay, strike on the transmission line or close to the transmission line. Okay, so this shows a map, okay, of the thunderstorm days around the world, okay, where we can see the region, okay, near to the equator experience higher thunderstorm days, okay, compared to a region that there are regions that are located further from the equator. Okay, so if you look at Malaysia, so we receive around more than 140 thunderstorm days in a year. Okay, so some lightning incident in Malaysia. Okay, so kid, okay, so a kid that died, okay, because of a lightning strike, okay, while using a handphone, okay, and also, okay, a 17-year-old football player, okay, was struck by lightning, okay, while playing football. Okay, so quite recent, okay, last year, 7 cows, okay, so died because of being struck by lightning, okay, and also a man, okay, was found dead, okay, because of lightning. Okay, so this shows us statistics of lightning fatalities in Asia. Okay, so back in 2009, okay, so taken from referred, okay, to this paper. Okay, so we can see the highest number of fatalities, okay, in Asia in 2009 is India, okay, followed by Bangladesh, okay, Vietnam, okay, and also Malaysia. Also suffered, okay, quite high number of lightning deaths, okay, in 2009. Okay, so next, I'm going to talk briefly about how lightning affected, okay, our power system supply. Okay, so especially in 1992, okay, so a major power outage, okay, happened in Peninsular Malaysia, okay, when a lightning strike a grid, okay, consisting of 4 power lines in Terengganu. Okay, so most specifically at Parker and Teluk Kalong. Okay, so it caused major power outage. Okay, and the power was restored, I think, between 6 to 10 hours later. Okay, all right. So some power system outage, okay, due to lightning in the world. Okay, so we had 1997 case transmission line failure, okay, because of lightning strike, okay, in New York. And then 1999, okay, in Sao Paulo, okay, Brazil, okay, it caused power outage. And then 2008, lightning strike on power line in Hawaii, okay, USA. 2010, lightning strike, okay, causing blackout in Darwin, okay, and the other recent, okay, major power blackout, okay, was in England and Wales. Okay, so it was due to lightning strike. Okay, so some safety tips. Okay, so we know that, okay, lightning pose a danger. Okay, so how are we going to stay safe? Okay, so even though our home, okay, is a shelter, okay, during a lightning storm, we still might be at risk. Okay, it was reported that about 1/3, okay, of lightning injuries occurs indoor. Okay, so even indoor, we can also get injuries, okay, or incident due to lightning. Okay, so some of the tips, okay, on how to stay safe, okay, during lightning. Okay, number one, avoid water, okay, during lightning or thunderstorm days. Okay, so do not bath, okay, shower, okay, wash dish or have any contact, okay, with water during thunderstorm. Okay, because this is because lightning, okay, can travel through the building's plumbing. Okay, so the risk of lightning traveling through plumbing might be less with plastic pipe, okay, rather than metal pipes. Okay, but if you do not know, okay, what is the type of piping in our house, okay, whether is it metal pipes or plastic, okay, it's better to stay away from water. Okay, and then don't touch electronic equipment. Okay, so this is because most of the electronic equipment, okay, like fridge, TV, microwave oven, okay, they are connected to electrical outlet. Okay, even our computers, okay, laptop, okay, washer, dryer, okay, and everything. Okay, because lightning can travel through electrical system and any metal wires, okay, in a concrete wall or floor. Okay, and then avoid windows, doors, porches, and concrete. Okay, because lightning can travel through any metal wire or bars in concrete wall or flooring. Okay, then don't use a corded phone. Okay, so this is corded phone. Okay, phones are mainly for the LAN. Okay, connect for the LAN phone, because it is connected. Okay, through the it has a wire connection. Okay, so it's better to use cordless. Okay, cordless phone. Okay, if you still want to make a call during lightning days. Okay, so let's say if we are outside. Okay, if you are outdoor. Okay, during a lightning. Okay, so sometimes we can we have other activities outdoor. So some of the lightning tips. Okay, okay, so check the weather forecast. Okay, because if a forecast calls for thunderstorm, okay, so it's better to postpone our activity, okay, change our activity to something else, to indoor activities, okay, instead of proceed for the outdoor activities. Okay, and then when thunder roars, okay, go indoor. Okay, so this is if you are close to our house, okay, or close to any building, okay, so it's better to go indoor. And then separate from others. Okay, when we are in group, okay, when we heard a thunderstorm, okay, or lightning, okay, so it's better to stay separate from others, okay, because it can reduce the number of injuries if lightning strike the ground. Okay, and seek shelter immediately. Okay, so this is quite common. Okay, so more tips, okay, for the outdoor safety. Okay, so don't stay in open vehicle, okay, like a motorbike, okay, or a car, okay, that where the roof can be open, and then avoid open spaces, okay, because lightning, okay, so we know lightning can strike anywhere, okay, can strike ground, and then don't stay near the tall structure, okay, because when there's a tall structure nearby, okay, lightning, it is likely that lightning will strike the tall structure, okay, and we can get a shock, okay, when the lightning strike the tall structure, okay, even though we are not touching the structure, okay, even if you are stay close to the tall structure that is being struck by the lightning, okay, we can also get a shock, okay, and if you are on the beach, okay, so return to shore immediately, okay, right? But basic tips, okay, when we heard thunder, go indoor, okay, so this is the basic tips, okay, to stay safe from lightning strike. Okay, Dr. Go, I guess that's all from me for this round. Okay,
Thank you so much, Dr. Hagley. You know, I mean, so what you have just shared, right, it just reminds me and keep reminding me about, right, beautiful is not always harmless. I used to admire the photos, right, showing lightning. It's just magnificent. I love that. I dislike thunder, but I love lightning, even in real life. So I think there is something that, right, to remind all of us as well. I will now, right before we go to the next session, we have 2 sessions for today. It's already right to ask questions about, I think each of the speakers. I have 3 questions here. I think the first one, right, is regarding this one I would like to address, yeah, to Dr. Hasley. When you mentioned about resiliency, would you like to, Prof. Hasley, I'm sorry, yeah, would you like to explain or describe a little bit more the concept of resiliency in this context, especially when we talk about energy, and that's right, like, you know, now, right, Malaysia is committed already. We are talking about net zero. How that is linked with the energy sector?
Okay, thank you, Dr. Go, for the question. Can you hear me, eh?
Yes, loud
All
and
right,
clear.
okay, all right. Okay, so if we talk about the concept of resiliency, as I stated earlier, resiliency definition is the ability to limit the extent or severity and duration of system degradation during or following extreme event. For example, during the flood. So as we know that some of the substation need to be switched off, but we need to find a way how we can reroute the power supply. And therefore, we need to have a proper plan. And how this relate with the net zero carbon, for example. So if we talk about the one of the way to improve the resiliency of electrical supply industry is through making the system, number one, intelligent, number two, strengthen the system. Therefore, renewable energy can come to the picture whereby the renewable energy, it can be formed as a microgrid, mean the solar panel, for example, in easy words, solar panel installed at our home. During the power outage, due to whatever reason, flood, for example, our home still can survive because we have a solar panel. So this is how renewable energy relate to resiliency. And in fact, if you look at the way to improve the resiliency, one of the way is to increase the renewable energy participation in the grid system, so that anything happen, renewable able to supply at least for some duration of time. It cannot be for long because, as we know, depending on the capacity of the battery to store the power from the solar panel. But at least at certain time, it still can have the electricity energy by having a lot of renewable energy. And by having renewable energy, of course, we will reduce the carbon because if you look at the data, roughly 1 kilowatt hour will produce 0.6 kilogram of CO2. So it's very huge number of CO2 produced from the conventional power plant based on a coal power plant. So if we can increase, which has been stated in the National Energy Policy 2022 to 2040, in 2035, around 40% of the electricity energy must come from renewable energy. This is how resiliency related with renewable energy as well as net zero carbon, as Dr. Go asked. Yeah, so that's my answer, Dr. Go.
To know, one is about, I think, intelligent as well as the efficiency. And I was just wondering, right, when we talk about these roadmaps, right, to net zero, we are talking about, right, to make sure that we have this efficient, right, energy. How do the end user, how do the society, civil society can contribute to this entire idea then? Yeah. Any thoughts on this? Yeah, from the panel? How the civil society can contribute? You know, we always talk about, right, the supply side, how we would like to fulfill, yeah, the demand, how we want to make sure that, right, the supply is efficient and is intelligent, through intelligence that, right, we ensure efficiency. What do you think about the civil society can contribute? When we talk about stakeholders engagement, I think that, right, we would like to work together. Any thoughts on that? Any panels?
Maybe who want?
Okay, right. Yeah, let it go.
Yeah. Yes, please. Dr. Hasley. We have two Hasley here. One is Prof. Hasley, and the other one is soon to be professor. I'm sure, inshallah, you will get it. I'm sure. But then, yeah, Dr. Hasley. Yes, please.
Okay, thank you, Dr. Go. Okay, regarding to your question about how society can play in supporting towards a smart, or what is it? Smart distribution, smart system, smart power system, for example. Okay, in my opinion, okay, one of the ways would be okay. So currently, TMB is changing, okay, the existing power meter, digital power meter, to what we call as a smart meter. So the usage of smart meter is to allow the electricity bill to be generated more efficiently, and then the meter reading, the power consumption can be read much easier, okay, because they can the TMB personnel, they can read the bills without going to our house one by one. So that is what the smart meter is. So what society can play the role is by supporting the TMB in changing their existing digital meter to a smart meter. Okay, because there are many challenges faced by TMB to change the meters, especially some of the society residential areas. They are quite reluctant to change the meters from existing meter to smart meter, yeah, especially from mechanical meter to a smart meter, because they are afraid that the electricity bill, number one, the electricity bill will be higher, okay, when they change from old meter to new meter, and number two, they're afraid of the radiation emitted by the smart meter, because smart meter is using radio frequency signal. But it's safe. Smart meter is very safe. Even the RF energy produced by a smart meter is much less compared to our phone. Even our phone is radiating more RF energy. So yeah, the TMB has been doing quite a lot of road show, okay, about the smart meter. So I think if the message is delivered properly from TMB to society, yeah, I think the society can play a role in accepting and giving cooperation to TNB to change the existing meter, existing digital meter or mechanical meter to smart meter. Yeah, so that is one of my opinion.
Yeah. How about, thank you so much, and Dr. Hasley, because I really acknowledge, right, the importance of what we call SEPA, yeah, the communication, education, and public awareness about, right, what we are going to do or TNB is going to do or is already doing it, actually for a collective, right, interest and welfare as well for the future, which, right, maybe at the moment, right, it has not been that effective. So SEPA is really important then, I think, to the SEPA's efforts. Dr. Lau, being economist, I always, right, curious about, right, how convincing economists can be, because, right, economists are able to show with the figures as well. And knowing that's why when we talk about economic benefits or cost benefits, right, analysis or study, when we talk about power outage, it is not only, right, the loss at the individual level or household level. We are talking for the national level. Yeah? And I would like to get some of your view about how this have impact. The power outage, right, have impact Malaysian economy, especially, right, when we talk about the real term, the tangible monetary term. Then, if you would like to share on that perspective, thank you.
Yeah, okay, thank you, Dr. Go. Okay, I think for estimating the in terms of the cost, of this power outage, basically there are ways to estimate it, and one way, of course, is the cost benefit analysis. Okay, but that's one of the way. And of course, recently we are looking into another method that is called willingness to pay, for example. So, for example, let's say there's a new system that install and that will improve so-called the distribution system. Okay, so what do consumer, are they willing to pay for this additional improved system? Okay, so this is another way to look at this issue, right? Because we need to use better technology, right, to address this power outage. Okay, so coming back now to my earlier discussion that is on SciFi and also SciT, right? Okay, so from our the data, our analysis, so we found out that basically, of course, as we expected, there's a negative association between the power outages and also and economic growth. So power outage, of course, it will lead to disruption in the production, in the factory, in manufacturing, and so forth. Okay, and then we actually use some data from this MIDA, right? From investment from MIDA. Okay, and from our papers, actually we found that construction sector followed by mining, agriculture, manufacturing, and services sector. So in terms of but this is just by number, but I think all these sectors are affected. Okay, so let me repeat: construction sector followed by mining, agriculture, manufacturing, and also services. Okay, so and of course the duration, as we estimated, our duration is from our data is 86 minutes. Okay, 86 minutes per customer per year, and also 2 times in a year. That is from the data we have. Okay, so there should be more avenue anyway, sort of to overcome these power outages. Okay, I pass back to Dr. Gong.
Thank you so much, Dr. Lau. Yeah, just thinking that when we talk about the construction industry, mining, and this is when we talk about, right, the very real tangible economic loss. But at the very personal level also, I was just thinking that how it actually also affect when we talk about in the hospital, the outage itself. Of course, right, they have the system to stabilize, yeah. But imagine that if that happens, right, in a smaller clinics and all this, and we are talking about the whole system, how will support our healthcare system in the countries as well. Yeah. Now I have a question. Actually, it's not from me. It's actually I'm reading from the chat box as well. The questions is that I think Dr. Hasley in your slide mentions about there's a graph showing about the lightning side incidents. And interestingly, according to the appendix is that, yeah, all genders, right, they are male. Is there any analysis on that? That why only males that actually got involved? Is that because of the outdoor activities that, right, they are participated by the male? Yeah, is there any reason of that right has been reviewed or discussed before? Because I saw that I think like in other countries also that they have, but they have also like female that involved or affected by the incidents. But in Malaysia, it's like purely male.
Okay, thank you, Dr. Go. That's very interesting question. Okay, actually, I think that there's no I think further research done dig into why more male in Malaysia suffered from deaths due to lightning. Okay, but I think in my opinion, it's most likely that males are usually involved in more males involved in outdoor activity like going hiking, go to fishing. Yeah, because most of our fishermen are males. Okay, they go to the middle of the ocean, hiking, and also doing outdoor activities on the mountain. And also maybe this is just my opinion. Maybe they are not. They don't are not aware of the dangers that may pose by the lightning when they are carrying out the outdoor activities. Yeah, but in my opinion, it's because of more men involved in outdoor activities. So that's why the probability of getting struck by lightning is on the men.
Yeah, I think that is really interesting, right? To start revealing and taking into consideration is that how occupation or even economics activity as duration that the incident took place, actually, yeah, to see the trend and to explain the graph or the statistic itself. Anyway, I think I will stop here as for now and then try move quickly already to the second session. And this one, I would like to again call upon Prof. Hasley. I was made aware that your team are doing research, related to the power outage, in relation to flood, very specifically. Could you share with us what are the research scopes about? And why you conducted such research and how it actually can help to minimize the impacts of floods if you take a look in put it in the context of climate change and power outage here.
Thank you, Dr. Go. All right, so basically the research, as Dr. Go explained at the beginning, is interdisciplinary research. Therefore, in this group, we have engineers and also from economic. So the idea of the work is here, the title is to improve the power grid resilience in Malaysia and also the economic benefit. So the power grid resilience here is referring to the two areas, whereby the first area is looking at the transmission. This area is covered by Dr. Hazli Azil. He do a research to find a way how to minimize the impact of lightning, to be specific, how to use a new technology, for example, placement of surge arrestor, so that the lightning impact can be minimized and reduce the outage due to the lightning. And for me, my scope is looking at the distribution area, especially due to the flood. So in this scope of work for the research in distribution system, we would like to study how we can predict the amount of the flood, the movement of the flood whether the flood will go pass through the substation, and if that happen, what we can do. Can we reroute the electrical supply system to avoid the flood? So this is the scope that covered by my research team. And another aspect, which is economic, was covered by Dr. Lau from economic. He will look at the impact of economic due to the power outage, specifically due to the flood or also due to the lightning. So this is overall what we are doing in this research. And the benefit of this research is we want to reduce power outage due to the extreme weather. And we want to know what is the economic impact, because maybe the economic impact is not really studied well in the past. So specifically, recently, there are a lot of flooding that happened that caused a lot of power outages. So this one need to be studied so that we can think of a policy maybe, so that the country can be prepared well before this happen. And for example, a proper plan, how we can deploy the generator set to the affected area, and also how we can ensure that before the flood happening, we can switch off the substation before it is explode due to the short circuit. So this is overall in briefly what we are doing, Dr. Go, in terms of our research. Yeah. So thank you.
Thank you, Prof. Hasley. I mean, for the overview. Just wonders, right, Dr. Lau and Dr. Hasley, would you like to share as well, right, especially when we talk about, right, the sub projects that, right, you are directly involved in? Maybe Dr. Hasley first. Yep.
Okay, thank you, Dr. Go. Okay, maybe I would like to share a screen, my screen again. Okay, so I'm sharing a website, okay, of my research lab. So the research related to lightning to this project is improvement of transmission line protection against lightning strike. Okay, like just now Prof. Haji mentioned, one of the sub-project in this program is on how can we help industry in improving the transmission line protection against lightning strike. So we are evaluating how is the lightning patterns on the transmission line and the transmission tower, and then we propose how are we going to protect our transmission line from being struck by the impact of lightning strike on the transmission tower. We cannot avoid lightning from striking our transmission line or transmission tower. But what we can do is to minimize the impact of lightning strike on the transmission line. So to find the optimum or suitable place for the protective device to be installed on the transmission line. And then to design transmission line protection to mitigate the impact of the lightning on transmission line, and then from various techniques on how to overcome the impact of the lightning strike on transmission line. So we compare and find out what is the best way to overcome the situation. So this is one of the projects that I'm currently involved with my team. Okay, we have I have one of my research assistant doing the project. So further details can be referred to this website, okay, umhbl.um.edu.my. Okay, that's all. Dr. Go.
Yes, interesting. Dr. Hasley, just a follow-up question, right? Do we already, I mean, this is a very layman question then. from the lightning, right, it channels so much of energy. Do we store those energies generated by lightning? And how we do that? What's the current gaps that we are having when we talk about, to get right different source of energies?
Okay, thank you, Ratiba. Okay, that's a very good question. Actually, there has been research done on how to harness the lightning energy in overseas. But the problem is that although the lightning energy, one lightning strike, it consists of up to I think 1 million or 1 megajoule. Okay, it's a huge amount of energy produced by one lightning, but the problem is the duration of every lightning is very short. So in fact, if we try to harness the energy, the lightning energy, we try to store in a storage system, still it's not enough to power up a certain device or to become an alternative source of power like renewable energy. So it's not really today I would say it's still not practical to store the energy of from lightning and to make use of it.
Yeah, good input on that, and learn something new again. And last but not least, of course, right, to Dr. Lau, if you would like to share with us, right, more specifically about the sub-projects that you are directly involved in.
Okay, thank you, Dr. Goh. Allow me to share my screen.
Yes, please do.
Okay, as I mentioned before, the first part, can you see my screen?
Yes. Would you like to share on the presentation mode? Yes. Thank you.
Yes, yes. Okay, thank you. Okay, so as I mentioned in my first part before this, I was discussing about this is the data from the Energy Commission, and we get this data and then we do some modeling on it. Okay, and as you can see from here, there are some let me around to adjust this. Okay, so I mean in 2020, this is the report published by Energy Commission in 2020. So the number of electricity supply interruption in Peninsular Malaysia increased from 58,000 cases to 69,000 cases in 2019. Okay, and then meanwhile, the electricity supply interruption remains high in Sabah, 20 over 1,000 cases, and also Sarawak 6,000 cases, around 7,000 cases. So it is important to quantify the magnitude of the power supply disruption on the country's economic growth. And of course, in our study, basically, we have a number of my colleagues, Dr. Ilya, Dr. Diana, and also Dr. Nurhuda. We work on this together with my RA, Mr. Yi. So we are looking at the impact of these power outages, and we measure in terms of frequency and also duration. So this is something in a way. I mean, as far as our literature research is concerned, we are not seeing a paper that use frequency and duration. Okay, so this is something new or something novelty in our research. So the scope, we actually have currently have work on these two papers. The first one that is looking into the impact of power outage on economic growth using SCID and SciFi together with the state economic growth data and also sectoral growth. And second paper, we extend earlier work and include the renewable energy as a moderating variable. And renewable energy can be distributed into solar and also hydro energy. And I just want to share some of this. Let me, whether you can see this clearly. This is our, in our study, we actually generated this thing called the marginal effect, right? So I think we need to show, okay. So looking at the figure 1, the power outage measured by the SciFi is found the negative significant on economic growth. The share of electricity generated from renewable energies is at the minimum level, 7.41%. The negative effect on the growth corresponded to the intercept and the solid margin effect line, negative 0.0174 percentage points. However, the negative impact diminishes and become insignificant with the rising share of renewable electricity production. So basically, This graph shows that if we are able to increase the share of renewable energy, electricity production, then this marginal effect of negative effect on the growth will reduce. Basically, this is the idea of this graph. Let me go to the next graph. So the next graph is that in figure 2, additional 1 hour increase in the power. Let me see. Interruption that an average customer experience is in a given year is found to reduce economic growth by 0.350 percentage point. However, the negative effect on growth is reduced and become insignificant with the rising share of renewable electricity production. Taken together, the margin effect diagram provides a clearer evidence on mitigating effect of renewable electricity production in the power outage and economic growth relationship. So basically, here again, it shows that if we are able to increase the renewable electricity production, then we are able to so-called mitigate the negative effect on growth. Okay, so this is the latest finding we have. Okay, I pass back to you, Dr. Kaur.
Thank you so much, Dr. Lau. I can see that, sometimes it's that writing for academics, right? We try to use the layman words, right, to communicate with the general public, but that's right, behind the scene, there's so much of works that has been done that, right, sometimes it is not easy to communicate, yeah? And I really appreciate, right, the works that, right, are done by the team, yeah, under this IIRG program. Just a very quick question, Dr. Hasley, how long is this IIRG program and which stage it is now?
You ask me or Dr.
Yes,
Hazli?
Dr. Hasley.
All right. Okay, so tak apa. Okay, Dr. Go, for this project actually is already almost 2 years, and we got extension until this May. This is due to the COVID lah. We blame the COVID also because when we started in 2020, end of 2020, so at the time we have some difficulty to get student and other things. But at the moment we are finishing. I believe that myself, my team is almost finished. One of the student is almost finishing the thesis writing related to this work, and basically we have some result to relate to do some prediction of the flood in terms of raining, and also what is the height of the flood and how it will, what is the threshold value that can cause us problem to the substation. And Dr. Azli also, I believe the work almost finished. The student is working very hard. The same goes to Dr. Lau. So, however, I think we still may need to have some time to, in terms of tidy up the work in terms of the software development, because we want to develop some software to do some prediction. So that one we will do some extension after this project is ended this May, I believe. Yeah. So Dr. Go, that's all.
Thank you so much, Prof. Hasley. Okay, we just received, right, that's 2 more questions from the floor. One is that, right, very, very interesting. An attendee is asking, what is renewable energy? I think like this is something that we in academia, or maybe some of us that would assume that we all know what is renewable energy, but this coming from the floor. Yeah, I think this is where, that's why this is a good platform that we communicate as well, and to share what means by renewable energy there. Yeah. Anyone would like to take up this question? Very simple term. Very simple question.
Yeah, maybe allow me to answer this. I think because I used the term just now. Okay, so renewable energy here we actually refer to solar energy. I think, as you know, that recently in Malaysia, right, we have seen more households they install this solar panel, right? Especially all those on the landed property, right? terrace house, you can see some of them already installed. And I think another one is hydro, right? Hydro, like our Bakun Dam hydro, right? So there's also renewable energy. Okay, I think these are the two main renewable energy we can source, right? Yes, any maybe Dr. Afu, you want to add?
Yeah, thanks, Dr. Lau.
From engineering.
Yeah, that's very good answer from you from non engineering and non-science background. I think you have answered quite well. Okay, just to add on, okay, actually renewable energy, okay, as the name implies itself, is energy that can be derived from natural resources. Okay, for example, like from sunlight. Okay, so just now Dr. Lau mentioned about solar energy. So from sunlight, okay, sunlight is one of the renewable sources. Okay, where we can obtain, we can convert the solar energy, okay, from sunlight into electrical energy, and also we have wind. Okay, so wind is also another type of example of renewable energy. Okay, it comes from natural source. Okay, in our atmosphere, so we can harvest a wind and turn it into electrical power. Okay, to power up our system. Okay, of course, there's a certain method of conversion. Other examples also is on heat energy. Okay, geothermal energy, biomass, okay, and any source, okay, that we can obtain. What else? Yeah, but there are some examples, okay, of renewable energy. Okay, but commonly and also hydro, yes, water. Commonly in Malaysia, we are using hydro and also solar, okay, from the sunlight. Okay.
Thank you so much, right, Dr. Lau, and then Dr. Hazli as well. I think that I hope that this is useful and helpful, right, to enlighten our audience here. There's also one more question that I would like to address here as well. It's from a very young participant, a young attendee, right, in this forum, and it was asked as such. How, as a youth, what would be your advice, to use, power or electricity, to be specific, effectively at home? How can I do? What can I contribute? Anyone would like to take up this question?
Okay, Dr. Go, maybe I go first lah, and then the other can add on. All right, thank you for the youth who attended this forum. I really appreciate for those who are attending this forum today. I hope it will highlight some of the new knowledge in terms of electricity. Okay, as a customer, actually everyone can play their role. I mean, the youth, the parents, and especially the youth, because I have teenagers at home, 6 of them. So we can see that usually these teenagers, they are not really care about the usage of electricity. I mean, they just on the light in the toilet, for example, and did not switch off on the aircon or the fan and not switch off. So actually, the parents need to have a role whereby need to continue advise our teenagers, our kids, so that they understand what is the impact if we not use electricity wisely. Because when we use electricity, every kilowatt hour, actually at the back, there are a power plant generation, maybe based on coal, that will generate power, and at the same time, it will release harmful gases to our environment. Yeah. And also maybe the teenager, our kids, they not pay the bill, so they don't see the impact. But we are the parent, we see that. So as a teenager or the parents, anyone at home, we need to use electricity wisely. We use when we need it, and we need to switch off it. And another thing is that, if possible, we need to use efficient equipment. Efficient here means easier manner is that if you look at the equipment at our home, look at the energy label. There is a label A plus, A plus plus. Sometimes they put star. Many star is better. What this mean? The same equipment, but different efficient, it will come out with the same outcome, but to get that outcome, the energy use is more. This is inefficient. So everybody need to look at this, and because it will help us to save our electricity bill. For example, at aircon, we use nowadays inverter base, the same power use, but the output is different. Okay, so it will reduce the bill. And also we need to use LED light, for example, and at the LED light, there is a labeling. So we choose the good one. And now it's become cheaper in terms of pricing. So I think everybody can afford it, and everyone need to play a role to do this. For example, also to cleaning the fan, for example. Maybe some of you not realize when there are a lot of dust in the fan, it becomes slow. You can check, and then you need to clean, and you'll see it become faster. So this is simple thing lah. For example, if you want to hot water, use gas. Don't use kettle, because it really consumes a lot of electricity consumption. Yeah. So I think that's all from me. Okay, Tego, over to you.
Thank you. Simple tips, but very important. I think living in the world today, I think we have not been thinking about things integratedly. For instance, people are talking about environmental protection. Many would imagining about protecting the trees, protecting our coast, but then people seldom relate that back to energy consumption, energy savings that we can contribute at the individual level. I think this is really very interesting. And the other part is that I would like to highlight is that when we talk about use, I always remember a very dear colleague from the UK based at Exeter University always mentioned about the use are very, very important. Why? We talk about climate change, and we are talking by our prediction is always at 2050. The youth today will be the adults that time. They will be the one of the receiving end of what we are actually contributing or destroying today. So it depends on us. We would like to save or we would like to destroy. Again, is that the youth needs a voice, and that's why they can contribute, especially with the new generations, the youth generations that so much tech savvy, a lot of energies actually are involved in the process of actually to live the daily life then. And I think we are getting there. 2 minutes, and I would like already to sum up our forum today. I think really thankful to Prof. Hasley for mentioning about and also sharing with us about the power shortage and how that is related to climate change. Then we have Dr. Laus give us from a very different perspective, the economist perspective, which we know that these two are linked together. And then Dr. Hasley, my favorite topics about lightning, but I say it is not that safe. Anyway, with the projects also that I think it is coming to an end already by mid 2023, and I see there's a huge potential for it to be scaled up again by even embark into the next interdisciplinary projects to work with the psychologists to take a look on the human behavior, how to engage with the end users, to work with the urban planners, to look at the flood, mitigation or prevention in terms of land use planning, or even work with the meteorologists as well. I thought that your team is really diverse, and that can be even enriched even further. Last word from each of the panels. Prof. Hasley.
Okay, thank you, Dr. Go, for summing up our forum today, which is very nice, very compact. So from me, I think everyone need to play their role. The parents, the kid, everyone, no exception, in terms of protecting our environment, our world, by doing what we can do. It's from the perspective of electricity, there are a lot of things that we as a user can do at home for start. And I believe that if everyone play their role, the government, national energy policy or net zero carbon, it can be achieved before 2040. And therefore, everyone need to have their good attention and play their role to ensure this. Thank you, Dr. Go.
Thank you, Prof. Hasley, for your kind words and wise words. Dr. Lau, over to you.
Okay, thank you, Dr. Go. Okay, I think I personally also learned a lot from this session from other panelists, Prof. Hasley and also Dr. Hasley. And then also I think as simple as tip as switching off when you do not need the power, that is very important. Okay, I think a lot of us are not aware of it. And I think from this research, I think from the research side, I think personally we are able to explore something new using the SciFi and SciD data and to come up with this margin effect. Personally, I feel that. And then also from the result, we also found that by increasing the renewable energy, okay, the use of renewable energy, it will reduce the impact of these power outages on our economic growth. Thank you.
Thank you, Dr. Lau. Really looking forward, right, to the final findings, right, of the projects as well. Last but not least, Dr. Hasley.
Okay, thank you very much, Dr. Go. Okay, for moderating this session. Okay, regarding to our research, my research, I hope that my research and team, I hope that our research finding can help the electricity provider, especially TMB, in protecting their transmission line more effectively. And there's nothing much to say, just okay for the public. When lightning roars, go indoor. That's the message. Okay, thank you much.
Interesting one and catchy too. I think with that, right, I would like to close the sessions with the final wish to everyone that right today is the World Wetlands Day. So it also reminds us, right, to the impacts on the environment, but at the same time, right, to broaden our perspective when we are concerned about the environment. And of course, right, through today's public forum, we broaden our concern and care to the environment through the awareness about energy consumption, also about right energy securities, right, especially in the future. Thank you, everyone. Bye-bye.
Bye. Dah close
Dah habis Tak, Dr. Azli tadi panggil dia masuk balik.